Okay, so if I remember correctly, the magnitude of vector x is actually, when we have an inner product space, is actually defined as the inner product of the vector with itself. So if that's the case, what we need to do for this inner product space is we need x transpose times the matrix 2, -1, -1, and 2 times x, right? Because what we're doing is we're replacing y with x. So the transpose of x is 2, 4. And then we need to multiply that by the matrix 2, -1, -1, and 2. And then we're going to kind of back end multiply that by x itself, which is another 2, 4. Okay, let's do our first multiplication here. So 2 times, what are we going to get here, by the way? This is a 1 by 2, and this is a 2 by 2, so I expect to get a 1 by 2 in return. So 2 times 2 is 4, and then 4 times -1 is -4. And then we're going to go over, so we have 2 times -1, and then 4 times 2, which is 8. So should get a vector that looks something like this. And then we can go ahead and simplify that vector. That vector is going to give us 0 and 6. Okay, so last thing we need to do is do the matrix multiplication here. So 0 times 2, and then 6 times 4. We're going to add those together. That should be our inner product. So our inner product here should come out to be. Okay, so basically you're saying that once we have the norm, we know that the norm squared is defined to be, whoops, I don't need this because I have that written down in the next step. So we know that the norm squared is defined to be the inner product of x with itself. And then we can go ahead and do these multiplications. And so we know that the norm squared should be 24, so that the norm of x should actually be root 24.